Hello, my name is Roxana Dumitrescu, and I will be your lecturer for the course Mathematical Finance 1 in a discrete time during this term. So the aim of this first session is to give you an overview of what we'll do together during this term. So first of all, which is the aim of this course? So this course aims to study the fundamental concepts related to mathematical finance and to show how to solve main problems arising in finance. The most important problem that we are interested in is the option pricing. Of course, that you don't know for the moment what option means, what pricing means, that you'll discover during the course. All these problems will be addressed in the simple case of discrete time models, and the main mathematical tools come from probability theory. So what are you expected to know at the end of the course? At the end of the course, you will have a strong knowledge in mathematical finance and in probability theory as well, being prepared to start the study of the continuous time equivalent problems. So first of all, at this stage, there are two things that I would like to tell. The first one is that normally you are expected to have some knowledge in probability theory, but even if you don't have it, you shouldn't worry, because in the second chapter, I will do the probability theory that you need in order to solve the financial problems. I will do it from scratch. Now, here you see that I used the terminology continuous time equivalent problems. What do I mean? So actually, what you'll see, and you'll understand even better at the end of the year, is the fact that in discrete time and continuous time, we have the same financial problems to solve. But the purpose to start with the discrete time, even the models are not realistic enough, is to insist on the financial concepts and financial problems, to understand them very well and to be able to solve them using very simple mathematical tools, okay? Because in discrete time, the mathematical tools which are needed are much simpler. And then for those who are interested to know more, you are very encouraged to take during the second term mathematical finance in continuous time, where you study actually the same financial problems but in continuous time and using more, let's say, complicated mathematical tools. Okay, so again, the purpose to start with the discrete time is in order to simplify the mathematical treatment, in order to be able to concentrate a bit more on the financial concepts and on the way in which we have to solve different questions arising in finance. Okay, so now I would like to tell you, to give you actually a very short description of the course. Of course, that many words that I'm using on this slide seem very strange to you at this stage. This is completely normal, but I just want to give you the flavor of what we'll do together. So we'll start with the study of the no arbitrage pricing theory. Then we'll continue with pricing and hedging of European derivative securities. Okay, so you'll see that European derivative securities are actually some contracts which have to be priced, and in order to price them, we have to use a given methodology, and the purpose of this chapter will be to learn us which methodology we have to use in order to price this kind of contract. And we do also more involved contracts like American derivative securities, okay? But you'll see at that moment. Then we study risk-neutral probability measures and the pricing formulas, okay, written in terms of risk-neutral probability measures. And here we have the big chapter on probability theory that we need and the relation with mathematical finance. So in particular, we study stochastic processes, of course, in discrete time, martingales in discrete time, Markov processes in discrete time. We learn about stochastic times, which will be used actually mainly for derivative securities of American type, and random walks. If time permits, we'll be interested in utility maximization and risk aversion. And the final chapter will be on models for interest rate and interest rate dependent assets. And again, if time permits, I would like to discuss with you the connection between the binomial models, so the model that we mainly studied during this lecture, and the Black-Scholes option pricing. So the Black-Scholes model is an extremely known model in continuous time, the simplest one. Again, not enough realistic, but it's like a first step that we should learn in continuous time. Of course, even in continuous time, there are models which are more realistic than Black-Scholes, but a bit more complicated. And what is really nice is the fact that there is a real connection between discrete and continuous time that we can see. So the idea is that this kind of derivatives, European derivative securities, so this type of contracts, their price in this model, Black-Scholes in continuous time, can be approximated by prices of the same contracts in the binomial model. Okay, so again, this seems not very clear at this stage, but what the message, the final message, is that there is a real connection between discrete and continuous time, not only at the level that the financial concepts are the same, but moreover that we can approximate prices of different contracts in continuous time using the prices in discrete time. Okay, so this is the message that I would like to let you know at this stage. Okay, so this is the course description, and now let's discuss a bit about the references. So the first thing that I would like to tell you is the fact that, okay, we have the organization of the lecture is the following. We have these sessions which are pre-recorded, then we have the live lectures where we can interact, you can ask me questions, of course that you can also ask me questions by email or during the office hours, but just only related to the lectures. We have the pre-recorded sessions, we have the live sessions, and we have the tutorials. And for each lecture, I will deliver you slides, very detailed slides. And you are also, I also suggest you to have this main reference that I'm using, is the textbook Stochastic Calculus for Finance 1, written by Shreve and published by Springer. So this is the main textbook that I'm using, especially for problems, okay, for the exercises that we solve together. And also in this textbook, there are many examples which are good to be read. But of course, that there are also other references that you are encouraged to read. The first one would be the one written by Kampisky Zastavniak. The title is Mathematics for Finance: An Introduction to Financial Engineering, again published at Springer. Here you have less mathematics, but you have more examples. So I think that for those who are really interested on the financial concepts, it is a really very good reference and not very difficult to read. Another reference which is very good is the one by Lamberton and Lapère, Introduction to Stochastic Calculus Applied to Finance. So this book treats both discrete and continuous time, so it might be very useful for you also next term, for those who will study Math Finance 2. And moreover, the mathematical level is a bit higher, but I think for those who are curious to know a bit more, it's a very good book. Another book would be the one of Pascucci and Rungelder, Financial Mathematics Theory and Problems for Multi-Period Models, again published Springer. And a last reference that I can give you now is the one by Pliska, a very known author in the field, and his book is called Introduction to Mathematical Finance Discrete Time Models. It's also a useful reference. Okay, so this is the course description. You know the organization of the lectures, pre-recorded lectures, live lectures, and tutorials. And of course, again, you have also office hours. And thank you for your attention, and see you soon.